Hello, John here again, and here we are, episode 2 of extending the Commodore BASIC. So, in the last episode, I showed you what I was trying to do, and I can show you again if you want me to, where we're going to try and extend the Commodore 64's basic commands by adding graphical commands to the basic library. And what we did last time is we converted what I'd written when I was a kid into, and we're using CPS instead of Kick, because I think it's only fair that we use a very good piece of software to do this. And in the last one, we'd coded the cartridge initialization system, and we've got all the constants in there and all the ROM routines that we're going to use. So now we have to code up the cruncher, the lister, the evaluator, and the executor. And that is probably what we'll be doing in this stream. So I said I would not be doing any coding in between the streams, but I didn't do any coding. What I did was I took all the variables out of the source when I was a kid, and I've just created them here. So when I in my assembler thing, it's called X low, X high, Y, U, V, S low, S high, U, but I've just put com underscore in front of it, so we don't get like Y. I don't want Y, the variable, being mistaken for Y, the register. So all I've done is I've hunted out every variable that I add in the assembly code, and I've put it in here. I've put comma in front of it, and I've given it a memory location, because remember, we're trying to build a cartridge, so you can't have the memory inside the cartridge space. All right, and so what we need to so what I've done is there's an area of memory O2A8 that is not used for anything. Let me see if I can find the memory, Commodore 64 memory map. O2A8. Here we go. There we go. So we have 89 bytes that is unused by anything. So from O2A7 to O2FF is not used by anything. And so we are going to use that as our variable storage space. And so I've started it with the base, and then I've just basically gone and said this is one more than that, and this is one more than that, and blah, 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 until I've got down here, and then I've done 5s and 5s, because I'm storing 5 letters. Or is that 6? Oh, make that 6. So that's all I did in between streams, and I didn't really think you'd want to watch me try and find every variable that we'd got, and so this is what I've done, and I've just added, so for every stream I'm going to put a line in that says what we changed and what we added. So what we need to do now is we need to understand how we're going to do this. Now I think I've still got the memory map over. Yeah, here we go. And what we're going to do is we're going to replace these, is it those? Yes, these jump vectors. So we're gonna replace the error jump vector. We're gonna replace that one. I think it's that one. Hang on. Let me check. Don't want to... Where's the initialization system? I think I've got it in here, haven't I? Yeah, here we go. Error. No, we're not replacing that one, so that's going to be still the same. Then we've got the tokenizer, which is this address, and that's where it would go to. We've also got the decoder and the executioner, and where, oh, the decoder is the lister, isn't it? Yeah, lister. And where are we? Yeah. Tokenizer, lister or decoder, bye-bye and evaluator. So that's these here. So we're going to overwrite these jump vectors with ours. All right. And so just to explain these jump vectors, this one is the jump vector for if you want the basic program to error. That's where it jumps. So when you call when you say I have errored, you jump to this place. That will then work out what the error is, and if it's not an error that you've defined, so it's not a syntax error or out of range error or stuff like that, then it will then pass it over to this routine, which then will do the error. But if it's an error that you have defined in the cartridge, then that error will then, you will process that error. Now this one is for when the system's just idling, and we're not going to overwrite that because we don't need to. This will overwrite because we need to check that it's one of our commands first, so we can tokenize it before we hand it over to the basic interpreter for them to do the rest of the tokenization. We've got what I call the lister. So basically, and this is done decoder, so it's the same thing. So basically takes, when you do list, it looks at the basic line and then runs it through the lister. And basically we need to look at it first to be able to find all our commands and then convert them back into the basic keywords before we hand it over to the basic lister for it to do all the normal basic stuff. Same with the execution jump vector and the evaluation jump vector. So that's what we need to do. So the first one we're going to do the tokenizer, because that is, well, I mean, to be honest, I mean, what's that one? That's doing the start. I'm not going to do the error one first. We'll do the tokenizer one first. So that is the thing where it takes our basic command and runs through it. So let's create a new file. So this is inc, and what did I call it? What did I call it? Or what have I called it? That's the one I want to know. What have I called it? There it is. So I called it inc basic tokenizer. So what we need to... Okay, mate, not a problem. We'll see in a bit. So let me just copy this bit. Now, a basic line is stored like this. When you type it in, it's for I equals 1 to 100. Print I, next I. 20, go to 10. And what happens is there's a routine that as soon as you press enter, takes this lot. So it does one line at a time, yeah. So if you've typed this in, it takes that lot and it puts it into the keyboard buffer, yeah. And then there's a 0 page routine called, and it's called two things, called character get and character got. And these routines are 0070 and 0073. Now, what character get does is it gets the next byte in either the basic program or the keyboard buffer if we're in immediate mode. Now, we're in immediate mode here because when you're typing in, you're not running the program, so it's called in immediate mode, or direct mode is another word as well that they use. Now, I used direct mode when I wrote the Kaidos commands for BASIC. So you could not put them into a BASIC program because you would get a syntax error because there was no tokenization whatsoever. Now, character got is it will return the current byte that it's looking at. So character get moves forward one byte, grabs the byte and then passes it to you. Character got allows you to go back and grab the byte again. Now, I don't know if this routine will have it in. So this page will have it in. There. So it's here. But it's not got the code for it. So we'd have to look at what the code is. So let me fire up Vice. So you can see what that routine is. Can you see that? Oh, no. So if we go into monitor, and I don't think I can boost this font up, sorry guys, but if we do disassemble 0700, 0070, this is it here. So in fact it's not 0070, it's 0073 and 0077. That's it. Let's get this right. And what it is, it's this routine here. So let me clear. No. Ugh. There we go. So we've got two pointers, 7A and 7B, which is this here. And if you notice, in default mode, it's looking at 0800. I can change the font. Where? Oh, is it in the settings? Where? Really? Can't see it. Oh, okay. There's nothing in view, mate. So there we go. So it's now moved. It's going. It's not at 0800 because I actually typed something in. So it's now at 0201, which is the keyboard buffer, I think. And what it is, this is the routine that you have to use when you run in a basic program. This is the routine that gets you the next command, gets you the next character, gets you the next function and stuff like that. So you have to use it. And the way it works is it increases, if you want to get the next character, it increases 7A. If it's not past the 0 page bound, it bypasses it, or it increases 7B, which is this here. So this is self-modifying code, original self-modifying code by Commodore computers. You know, so whoever says they invented self-modifying code, they lie, because it was already here. Alright? Then what it does, it checks for certain things like the colon. I think that's 3A's, the colon, isn't it? And a space, checks for a space, and basically it just returns back the either the character to you or the command. And that is something that you have to use all the time. So you can't just run through it yourself. So what you do is then you write the tokenizer around that routine to work. So let's get it started. Let's start coding this thing up. So we need to crunch, but we need to make it jump the first thing, and this basically that sets up the char get and char got routine for immediate mode. Then we initialize Y, and then this is where we start our looper. So what we do is we're going to load the buffer in. So we're going to load the buffer. Now I have no idea why they do buffer -5, and hopefully I've still got the buffer in here. Hang on. Where's my ROM locations? Oops, no, it's not there. Is it in the buffer? Yeah, there it is. So I don't know why, but I've looked at the ROM because I was trying to figure out why I was doing -5, and I looked at the Commodore BASIC ROM instructions, and they do exactly the same thing. So no idea. So we get it. If it's equal to 0, then we're going to jump away. And this is what I called the function when I did it, so I'll have to remember I've done it. Then we're going to compare it with quote. And if it's equal to quote, we want it to loop back round because we don't need it. So we're trying to strip out all the characters that we don't need. Then we're going to compare it, with little a. And if it's less than, loop back. And you'll see where loop back's all about. And then we need to compare it with that. Oh, my character set doesn't show it right. Let me just change the character set. We'll just change this temporarily. Oh dear. Where's bold? Where's bold? Bold, bold. There we go. Oh, can you see that? Can you see that? It's set bold. I will boost it. There we go. Right, can you see that? So it's a square bracket. Right, so it's a square bracket, and that is the top end of the things that we want. So there's a range where we want to look at. So this is branch of carry set. So all we're interested is in between the small a and the square bracket. So I think that's the entire characters that we've got. We're filtering out there. Then we store away our indexer. And lower X, store that in an indexer as well. And then we compare. So if it's anything, let's see, compare. Yeah, that's right. Yeah, if we compare it with 128, so that's a reverse character. We don't want to know it because we don't want to know reverse characters. And then if we've got through all that, we XOR it. So we remove the reverse bit. Now, the reason for this is it's something to do with the shift characters and stuff like that. Do you know when you can do poke, it's P shift O and stuff like that? It's just to strip out all the special stuff of the letter that we've, or the byte we've got, and then we'll be able to evaluate it. And now we can start the crunching. So we set the carry, and then we subtract what we've got left from our command list. Characters, comma X. So we're taking, so let's say right, let's say we've got our graphic command, yeah? So after this we should be just left with a raw G, yeah? And the way it works out what command we are is it subtracts that value from the command list start value, yeah? So if our first command, let's say if our first command was screen, and then we add graphic, which was the second command in the list of commands that we've got, it would take it would take S away from G, right? So we're subtracting S from G. Now, if it's equal, then that means we've got a match. So G, when you've subtracted G from G, we get 0. So if it's equal, we know we're on the right track. We've hit a command that starts with a G, right? So then we need to go to the portion. Then we compare it with 128, which is when, and you'll see what I mean by 128, because in the command list, the end of the command, right, in the command list is capital the character. So if we subtract this from this, we end up with 128. So 128, so we're comparing 128, which means we've come to the end of the basic command and we're still testing the characters and we've got to the base command. If we end up with 128 left in the accumulator, it means that we've found our command, because there's no way we could have got to 128 without it matching the command. So if it equals 128, then we go to done, because that's it. We've found our command. All right. So if we then load our command character, and if it's 0, yeah, it was 0, then we say that we are breaking out of the looper, because that means that we've got to the end of the command list in total. Yeah, it's a bit difficult to explain, because you've got a list of commands and you're testing a string of characters against your list of strings of characters, and it gets a bit, but at the end of the list of commands, if it's 0 at the end, so the next byte you get is a 0, that means you've run out of commands, that you've got no more commands to evaluate. If it's minus, then we need to continue. If it's plus, that means we're in the middle of finding our next character for that command, because we've found it was 0. It's not 128, so we've loaded the character and we've tested the character of the command, and it's not 0, and it's not, the 7th bit is not set yet. So therefore it's a valid character in the command, and we need to increase X, because now we're going to test the next character in that command with what we've got in our keyboard buffer. And if it's not equal to 0, as in it's not the X register is not looped around, then we go back. Right. If the 7th bit is set of the command, that means we've hit this. Right, so we found our command. So we are going and we load in buffer -5, y, increasing our character, our keyboard character index, and then we go back to finish off if we can find our, so we come back here to test the next character in the loop. Then if we'd finished, we're loading X from B1, because that's where we're storing it. What are we doing next? Oh, we're loading that should be the command number. So OB will be the command number. So if we matched up and it's the 3rd command in our list, then that will be in there. Then we're going to add it to our custom tokenizer. So we're starting our commands at CC. And if you remembered in the last stream, we identified that there's a space of commands that are not used by BASIC, and I think the last one is CC. So this will always be 1 or above, because there'll never be a 0. So we're going to add CC to it, which will give our tokenizer value for that command. And then we store it into the buffer. At X, because X is now our counter for our command index, not Y, which is the counter for the keyboard buffer indexer, but X. So this is a typical wedge. Yeah, you've probably seen the typical wedge, but this is the tokenizer bit of the wedge instead of just an interceptor, which most web wedges are, is where you intercept and you evaluate it, but you just don't crunch it, because you evaluate it and then you say, right, go run my command, which is what Kaidos does. Then we need to increase our character, we need to increase our command index character, need to load the buffer back in again, because we need to re-establish what's in the accumulator, and then we are shuffling everything down. So this routine shuffles all the characters down. So graphic would have been GRA. I'm going to count it here. 1, 2, 3, 4, 5, 6, 7, and we've now taken those 7 characters, and it's going to equal CC. So we're taking 7 bytes and making 1 byte, and so we have to shuffle everything down in the keyboard buffer. Yeah. So that's what we're doing here. Then we re-establish Y with what we've got stored away. This is the loop breaker. So INY branch if not equal to loop OT, which is up at the top, I think. Yep. So we're going back to the beginning. Don't ask me about these variables, that's what I called them, and I've got no recollection of why I called them that. So once looks like we've finished shuffling everything back, and now we're re-establishing the accumulator to evaluate the next command, because you never know, we might have more than one command in a line, and you'll see that we do later on, especially when we do the draw, because we have a draw basic command which will be tokenized, and then there's a TO2 that we do as well. So this is basically doing the whole thing again. Oops. Fat fingers, fat fingers. CNC HRT. And this is resetting the buffer once we've finished. So remember when we tested for 0? So this is now saying that this is the end of the line. So we've gone all the way through the line now, and we've been testing all the text against our commands. And where we've identified a command, we've converted that text into 1 byte and then shuffled everything up. And then we've carried on. We've carried on going until we found another command that was us, identified it, tokenized it down to our command number, shuffled everything up, and carried on until we've hit the end of the keyboard buffer, and that has just re-established the 0 at the end of the line. Right? And that's our cruncher. So I just want to make sure that I've typed this in right, because knowing me and my fat fingers, oh, there's a typo there, that's Q. See, fat fingers, break, load B, store YB1, load X, store X, come 128, loop in, XOR. And all I'm looking is the code that I wrote. That's all I'm looking at. Loop number, command list, comma X, loop back, continue with the loop. Loop number, so that's the command number, so we're then initializing it back. Ooh, hang on. Yeah, that's here. Get myself lost. And that's not good. I've missed a bit. See? I've missed a bit. I was wondering why I wasn't increasing OB. Now this is clever, right? Because they have used a byte here, and what it is they don't want to change A9. Right, A9. Let's find out what A9 is. It's a 6502 instruction. A9, I think it's LDA. Yeah, LDA immediate. Right. So what they do is, right, if they want to jump to next, which they do from here, yeah, they can jump to this and it's INY, yeah? But when they come through this, they don't want to increase Y because they've just loaded it here. So what they do is they put a byte in $A9, which is LDA immediate, and then it loads that into the accumulator, which then they overload on there. And it's a very clever way of getting rid of an instruction you don't need without actually getting rid of it, because they knew that they was going to be loading A here, so they put load A immediate and whatever INY is in INY. Where is it? INY C8. So basically it's doing, so if you don't do branch if equal to next, and then it goes INY load the buffer, if you come through here it says LDYB1, then LDA immediate C8, and then immediately overwrite it by that. It's very clever of hiding instructions when you don't want it, and I use that in other places where you don't want to increase your register because you're coming through the loop instead of bypassing it, and you can cheat by saying load immediate. I mean, you could say load immediate X if your X value is not being destroyed, and your next byte, you'll then consume that next instruction as a load instruction of that, and you just ignore it. It's very clever. Very clever how they've done that. And I think that's it. I thought there was a bit missing. So next is that. Loop in. Done is load that, add CC, store it. Then we've got the shuffle backer. Load B1. And loop OT. loop qt, loop bk. Right, so now we need our command list. So let me You're very quiet out there. Ooh, too many. Have I boring you? Yeah, it is heavy. It is heavy stuff, but it's the fundamentals of an interpreter. This is the fundamentals of a interpreter, and it could be any interpreter. It could be a C++ interpreter, Python interpreter, anything, but this is just the basic interpreter. That's all right, mate. Right, so our command list is going to be here. And basically all we're doing is, we're just doing this. So the first command will be screen with a capital N. Remember, the capital denotes that's the end of the command. So that converts into bit 7, I think. So next one, which is that. So we need the C. Next one, I'll just type a few in just so you get the message. So that's plot. So remember, it's always got the R point, the shifted character, text W, and then circle like that. So we'll do that, and then we've got to put the break in at the end, right? Now, I do that, yeah, and it's a throwback from when I was a coder on the C64, because BRK is 3 bytes, BYTE space 0 is more than 3 bytes. So that is the, but it's either that or you can do byte 0, whichever, but I always do that. It's an easier way of getting a byte 0 in there. And then we need the command addresses. Now I haven't spoken about this yet because we haven't got there, but I'll just put them there, and I'll put that in there. I think that's capital list, isn't it? No, well, I'll make it capital anyway now. Right. So, how do we make this work? Well, we need to now change the vector on here. So this here now becomes our vector. So we'll open that one up. And what I'm going to do is find the vectors for the other ones so we can try this out. So where is Vice again? So if we do the monitor and do memory 0300, so the first one is E3B8B. So E3 8B. Then we've got that one. Then we've got our tokenizer. So we're not bothered about that one. So the next one is A71A. And the only reason I'm doing this is because I've got a routine that's going to overwrite it. So that's the lister. Bye bye. Bye 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 bye. So that's going to be A7E4. So that's bye-bye, and the last one is A7E4 is AE86. Right, so this one is the error jump. This is our tokenizer jump. This one is our lister. Bye bye. And eval me. So we should be able to, so if I put that back in now, because JSR start will overwrite our jump vectors, we should be able to yeah, let's put a break on our here where we exit. Let's put a break there so it forces the emulator to break, and then we can see what we're doing, and we'll put a break at the start as well. So let's put a break there. Right, hopefully this will work. Hopefully. Oh, we got an error. What we are missing? Oh, okay. We are missing that because we haven't included it. I think that's how I spelt it. Yep. It's looking good. Overwrite that. Got the C64 open here. Get rid of the monitor. Oh, rats. Right, let's load it in. Get up. Right, so soft reset. There we go. Now, what I'm going to do is I'm going to type in a line of code. Ooh, would help if I could spell. Right, so that's one of our that's one of our commands. Yeah. So as soon as I press enter, we should break out because we've taken over the tokenizing routine straight away. So we've inserted ourselves in there. And it didn't break. Why didn't it break? Have I not set it right? No. We didn't overdo it. Have I missing something? We didn't overwrite it. Map vector, store it. So that. Oh, that's why I forgot that one as well. Let's do it in debug mode as well. Be able to see it better then. Okay, yes. Right, can you see that? Okay, so let's get them. Let's get the right view up. Okay. Six, 4, 7, 3, 8. So if we check 0300, we should be taking over. There it is, 8109. So we've now taken over the tokenizer, yeah, because that's our address there. So the keyboard buffer is at 0200 here, yeah. So let me type in a line of code. So here we go. So hopefully it'll break. Oh, it broke. It did break, but it didn't break how I wanted it to break. Ah! Let's do it the old-fashioned way. See if the breakpoints will go across. Toggle breakpoint. Toggle breakpoint. Right, let's see if that goes across. Right, soft reset. We should have overwritten. Yep, 8-1. That's the third set, yep. So put ourselves at the keyboard buffer. So hopefully we'll break. And it didn't. Damn. Well, there's a problem anyway. Oh no, it's doing it. Right, let's put a breakpoint in on R, so it's 8109. Let's just stop it. Oh, go away. Right, 8109, so we're going to put a breakpoint there, and we're going to put a breakpoint where the RTS was, which is there. Right, so we'll clear out this. Press F10. F11, start up. Right, so we'll do it again. So 10. Whoops. Graphic. Right, so as soon as we hit it, we should break. There we go. So as you can see, it's transferred what we've typed here and it's put it in here. Alright, so let's see if we can work this out. So there's the 0, so 43, 49, 48, 50, Where's the other bits? Oh, graphic, G-R-A-P-H-I-C. There we go. So that's the... So it's evaluated the line number and it's got rid of the space. So now we're at the graphic part. So this is the graphic text that we've and I'll do it. I'll try and write a big line in to show you. But what it's going to do now is it's going to try and find it in our system. So I'm going to put a breakpoint where we add our CC. So here, so I'm going to put a breakpoint here. So that's going to say it's done and found it. Right. So go through it bit by bit. So what's it loaded in? 47, which is here. It's comparing it to 22. It's not. Comparing it with that. It's not. Comparing with that. No. Right. Store Y away. Load X there. So we're starting the X. Load. Compare with that. No. Right. Now subtract with the first command that we've got. Now I think that's S for screen. There are F4. It's too big. So that should immediately. Ooh. Go and follow it. So it jumps away. Now it's going through our S, C. There we go. It's going through again. So it's reading the screen command, right? It's reading the screen line. No, the screen text until it hits that Shift N, which I think it's hit now. Yeah. So that's Shift N. There's the LDA, C8, so it's not increasing Y. And now it's going back to look again at the character to re-establish what it's done. So it's come back in, it's going to now subtract it. So this is the second command. And if my memory serves me right, the second command is graphic. So here we go. So it should start identifying that this is the command that it needs. So it sets the carry. It subtracts the first character in the second command. 0. There you go. Look, 0. AI 0. So that's G, and it found G. So it says, right, okay, I've identified it. So it comes here. So there's that load. This is where I was talking about where you can mask a character, a command away. So it's increasing Y. Then it's loading the next character, which is 52. Increasing the command character. Then goes back and says, right, I've got 52. Subtract the next character in that command with me. 0. Right, we're on a winner here. So it runs through and keeps running through. 0, 0. So we're on a winner at the moment. 0, 49, 0. Right, 43, 80. So that's now what's happened is it's so we've done graphic, and it's just subtracted the capital C from the little c, and it's come back with 80, and that signifies that was the end of the command in the cruncher. So as soon as it hits 80, it goes, right, that's the end of the command. We've identified what this command is. And then it adds CC look, and then it should store it in this first character here. Let me just check. 05, yes. Now that is wrong. Now why is that wrong? Because it's done 14 and it shouldn't be. It should be CD. So what have I done wrong? Oh, I see. I see it. Yeah, that's B. We are not increasing OB. Ooh, that's not good. Let's Store X OB, Inc OB, that's the command number, LDA OB. So why is it not? Why did it not pick it up? Because CC, hang on, CC plus. Yeah. So it's still, why did it pick, why didn't, let me just run through that again, find out what's going on. I'm not going to copy that in, I'm not going to copy that, I'm not going to cheat, I'm going to find out what I've done wrong. Going to find out what I've done wrong. So 8109 is there. So that's the first breakpoint. Compare, go to 841B, which is here. Do that, right. Now I think there's something wrong going here. I think there's something wrong here. OB, we need to keep an eye on OB. Need to keep an eye on OB. Right, 10. Graphic. Here we go. So we are up here. So we need to keep an eye on OB, which is A, B there. Because at the moment that's 4C. So let's run through it. So we know the first one's not going to do it. So OB. Why is OB still saying that? It should have reset it. STAOB. Did it not get there? There we go. OB is still 48. It didn't reset it. It didn't reset. Why did it not reset? That's why. Oh, come on, John. Need to be on the right one first. Right. Load. Okay. right, 10 graphic. Right, so now it should reset it. Right, OB, there it is. Come on, here we go. Right, we're on the right track now. So we're going to run through. So it's doing screen, the command screen first, which it will, of course, not do. Right, so it's increased OB, so that's command 1. So it's now going back. We should start seeing zeros. There we go. And then when we get to 80, so when it says 80, there we go. So is it 80? Right, we'll load X with that. So X is the current character we're going to be on. Load OB, which is 1, CLC, add 6cc, and then store it. So 0200, put it in. There we go, it's put CD on it. Better, that is better. And then it shuffles everything down. But because we was at the end, it's just put the 0 in. So it didn't need to shuffle the line down because there was nothing after graphic. Right? So if I press F11 now, and then do another line, but a really long one. Let's do a long one. Right. So 20 for I equals. This is where I can't find equals. No. 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 Where's equals? Oh. It's got to be here somewhere. Where's equals? / No? Ah! Is that equals? Yeah, that's equals. / Thank you. 0 to 100. Oh. Ah. Print I. Next. Right, this is going to be a long one. So now the difference is, right, when we scan, so this is all the information. When we scan this, we're going to scan we'll scan all this, but none of the commands will match what we want, right? So I'm going to press F11 so you can so when it comes to the end of it, so if I press F11 it will come to the end. There we go. So it's put, that's now in BASIC. So now what I'm going to do is, let's go back here, 30. I'm going to do screen colon graphic colon plot. Now there are 3 commands that I've got in my cruncher. So we're going to go through it now, and it should put here CC, yeah, CC, CD, and whatever plot is. So let's run through it. Oh, come on. Here we go. So it's found screen. Oh, look what's kicking in. Right. IRQ kicked in. Right. So it's found the first. So we've stopped at the found the first command. So this is going to change. So first one is screen. So SCREEN colon. Right. So it's going to convert it and then add it. Put the tokenize command there. CC. Then it's now going to, it should shuffle everything up. There we go, 3A, so that's there. Next one should be 47, should go there. There we go. Then 52, then 41, then 50, then 48, 49, keeps going to that's that. Then we've got plot, and there's the 0, so that's where it'll come out. There we go. So there's the 0. Boom. So now it's gone back through because it's now said, right, I've done one command, but I've got some more to do. So it's going to now run through. So we'll just quickly run through it. There we go. So it should have put in, come on, there we go, CD. Then it's moved the 3A, the colon back, and now it's trying to find the plot command. So we'll run through it. I've lost where, 3A, that's it. So that's the next one, the plot. So that's where the next one's going to go. So it's running through now. Here we go. All right. On there, press Alt and Shift using the left keys at left. Oh, right, okay. So it's their plot. Okay. Let's go back here. So we are still trying to identify our command. I think we're on a winner now. Here we go. Compare. Load in OB. So it's 2. So we should end up with a new command here. Add CC, store it. Then we're going to shuffle everything back, but it's 0. So it should just put a 0 there. There we go. So that has now crunched that line. So screen, graphic, plot. So all those characters, which has got to be 20 plus characters, and it's now crunched it to 1, 2, 3, 4, 5 bytes. And that's how the basic cruncher works. So these 5 bytes now will get passed on to the basic interpreter. They will not recognize any of these, and then this 5 bytes will get stored in memory. So let me just F11 and get out. So we're now back in here. The problem is, right, is if we do list and press enter, right, so it's going to tokenize the word list. So we're just going to tell it to go on. Can you see? It says 10, 4, 30, syntax error, because it doesn't understand our commands. It doesn't know what CC is, CD, CF was. So the next thing we need to do is we need to now do the lister or the detokenizer, yeah? So we've now proved that the tokenizer is working. So we now need to do the reverse. We need to take our numbers and bring it and make them into proper words, and that is called the detokenizer, or in my eyes it's the lister. So let's create hello. So let's create another file. So inc basic listener, I think that's how you spell it. Yeah, it takes a while to try and understand it, but once you've figured out the basic mechanics of how it works, the way I do it now, I can't remember what I did as when I was a kid, but I must have the same philosophy. But I just break it down into chunks. Break it down into chunks and try and understand the chunks. Right, so we're now doing the lister. I call it the lister. They've called it the decoding routine. Yeah. So I'm calling the lister. So vec underscore lister. Right, so what the lister's going to do is it's going to take the bytes, so the tokenized bytes, and then compare. Yes, it's what I do now anyway. So it's going to take the tokenized values now that's held in memory, not in the keyboard buffer, but in memory, and then it's going to take that tokenized value, find the corresponding command, and then display that. So that's how it's going to work, hopefully without an issue. So the first thing you have to do is you have to store the status away. I have no idea why, but if you don't, it goes all horribly wrong. So there must be a reason for it, don't know. Then we compare it with 255, which means end of, because there is a character at 255, I think it's the checkerboard. But 255 means it's the end of the lister, yeah? So lexit, so we're going to tell it to go to lexit. Then it does this lovely bit command, and we all know what that does. So so we're going to then test bit 7, and we're going to say, right, go to exit, because you should not have what is it? Oh, yeah. You can't have bit 7 on, not for the tokenized bytes, but the other bits. So like print John, quotes John. None of them should have bit 7 set. There should always be non-bit 7 bytes. So if you get a bit 7 byte in the wrong place, not in the tokenized byte place, but in every, then you exit out. Then we're now going to compare with our start of our tokenizing bytes. And if it's less than that, then we go to exit, because if it's less than that, we don't want to know about it. Just hand it over to the basic lister. We're only interested in everything that's CC or above. So then we pull back our status, set the carry, subtract CB, because you want it to come back with 1, 2, 3, 4, 5. Phone going off somewhere. Transfer into X, because that's going to be our index. Store Y in 49, because we've got to save it, because we're going to destroy it now. So, right, I have no idea what this label meant. I was racking my brains trying to figure out, and I think it's just rest. I don't know why. Some of my naming conventions was I was a kid are a little bit suspect, but there we go. So we are now decreasing the. Yeah, it's loop 1, but I don't know what rest means, seeing it's supposed to be the lister. So we decreased X, which is our command number, yeah? And then is it 0? So that's going off to the printing, because we must have found it. So now it's res loop 2. So we're increasing Y. So that's going to take it into 0, and then we LDA our command list, Y, branch is plus. We're not interested. We're not interested in what we're interested in when it does this, when the 7th bit is on. So basically what's happening is we're just cycling through the commands, yeah? So we're not interested with the lower case stuff. We're only interested in the shift characters, because that determines our next command, yeah? So we're so if we've got a command of a tokenized value of, say, CC, so when we subtract CB we end up with 1. And so then we know we've got to run through one command before we get to the command we want. So if it was, say, once we've subtracted CB and it comes back with 5, that means we've got to loop through 5 commands before we find the command we've got to print out. And that's what this is doing. It's just looping through, trying to find the command we need to print out. So here we are. So res print. And basically we just load the command list, and then we test for the end of the command, because remember bit 7 identifies the end of the command, and then we just print it out. Kernel jump chr out. Missed it. That's the one. So that prints out the character, and then branch if not equal to, so it goes back round. Then we got rest exit, and this is where we jump to 6EF, which is the basic lister. So once we've done our bit, we go to the basic lister and say, off you go, it's your turn. And then L exit. So this is where our exit goes. So we pull the status back, and then we jump to the basic uncruncher, sorry. I've got to look at that. What's the basic uncruncher? Run routines. Basic uncruncher. A717. And that, oh, got that 3. That's it. Because that's just going to jump, that the uncruncher jumps to our jumps, which jump vector, which then jumps to us, and we need to jump to the next one along. So that's it. That's the lister. So we haven't got debugger running, so let's run this. So before, if you remember, I think I've still got the breakpoints in. Oh, we'll find out. Graphic. Right. 20 screen graphic plot draw. That was another one, wasn't it? 30 draw, 40 go to 10, 50 for I equals, no? Equals. Oh, come on. Oh, I hate Vice. I can't find the equal sign again. / is not it. Shift / no. Shift back. What's equals again? Ah! Oh, whatever. No, it's hash on my keyboard. Right, so there we go. We've loaded a program up, and remember the last time I listed it, we had a syntax error on this line because it, line 10 came out as 4. This line it came out as syntax error, and what I've done is I've put some normal ones in so we can check that we haven't broken the basic lister. So if I type list now, hopefully it should list it out properly, because we've now got a lister in that takes our commands and re-represents it for the user. And it's, oh, poo. What have I forgotten? Oh, poo. You plank. No, I forgot to change the vector here. We need this one in its place. Right, let's run it again. F5. No idea what she's watching. Vet lister. Oh, and of course it's not going to work because I haven't even included it yet. Right. F5. Ten-4 big 10-4 big buddy. No. I'm helping develop this program, right? That's why when on the start page, it's got me all over the shop, yeah? Because I am helping Arthur write this software. So, in this version, I wrote the GitHub extension for this. The Git extension, so we could interface with Git, and I'm helping Arthur integrate Kick assembler into this in the next version that we're working on. So what I wanted to do was just to show people that even though I'm using VS Code and Kick, my first love and 150 odd videos of mine are using CPS. So that's the reason I'm doing this. So I thought I'd do this stream using CPS, as I'm using Kick assembling VS Code for Grid Runner and Hunchback. All right. So that's the only reason I want to show people that there is a piece of software out there if you don't want to use Kick and VS Code, because it is a pain. It is a pain at the backside sometimes, VS Code and Kick, as this has everything in it. It has everything that anybody wants. So, right, I forgot what I was doing. What was I doing? It was complaining about something. What else was it complain about? Oh, that. Invalid label? What do you mean invalid label? Oh. Yeah, Arthur's done a really good job. I mean, I helped. I mean, this Project Explorer, I wrote this. I rewrote his because there's a funny story to this, because the Project Explorer, when Arthur wrote it, was several hundred lines long. I did it, and I did it in about 40, I think it was. So it's a lot quicker. So we've been able to add extra bits in there, like the highlighter that tells you it's not there you go, that tells you how many bytes it is, and we've only been able to do this because I rewrote it. But I'm not taking the credit for the program, because the program is Arthur's. Yeah, I am looking at trying to extract the assembler out and write it in .NET Core, which means it will run on anything. So we could use VS Code and this and the assembler and stuff. But I'm also trying to look at trying to do the other stuff as well, and then have a library of stuff that we can use on anything. Right, back to the task in hand. So F5, let's see if it works now. So 10 print John, 20 go to 500, 30 graphic, 40 screen, plot, draw, graphic. Right, so now if we list it, we should not get any syntax errors. They should, those crunched values should come back to us. Get in there! Get in there! Get in there! So that's now taking our code. So if we do monitor and look at 0801, right, so this is the basic, yeah? So this is the basic. So this is the link to the next line. So the next line is 080E, which is somewhere over here. There we go. So this is line 10, print quote space quote John quote end of line, yeah? Then the next line jump 0818, so that's here. So this one says line 20 go to space 500. Then the next line, which is saying that the next line is 081E, yeah? So line 30, there's our special tokenized byte, CD. So if I just scroll down a bit, so CD is graphic, yeah? End of line. Pointer to next line, line 40. All right, CC, which is screen, space, colon, space, CE, plot, space, colon, space, DO, draw, space, colon, space, CD, graphic. So there we go. It's now evaluating the basic in memory and reconstituting it in as a list for the user. Wow, that was are you are you understanding what's happening here? Because I don't want to go running off and you guys saying I don't know what's going on. Do you understand the basics of those two functions, which is the cruncher and the uncruncher, as they call it, as I call it, the lister? So do you understand how the crunch is doing it? Oh, I'll have to give you a private lesson, mate. Hi Mike, how you doing, mate? Well, Microman, I mean, I was doing this when I was a kid, well, I was a teenager, and I'm telling you now, you know, me looking at it last year, because I started looking at this last year, because I've got slides and everything. Hang on, let me show you. I've got slides. I made loads of slides and stuff like that. Here we go. OSK Basic Development. I got the slides ready to do for the thing. I mean, I even talk about, when we get to the high resolution bit, I've got slides to talk about all that. But look, I did it all here, look. And then I explain other things and other things and other things and other things. So yeah, we've got all that to do, so it'll be a proper lesson, you know. Now then, students, calm down, put your books away, put that phone away. You know, that sort of thing. So, do these work outside of program listings? I'm not sure I'm not sure I understand the question. But yes. Let me load. Have I got? Oh yeah, I've got it here. Right. Let me load my original one. So it was master disk 1, I think. Yeah, graphics extension number 19. Right. So I know. Reset it. There we go. So there you go. 1985 when it was originally done. So if I type graphic now, yeah, you see it did it. Now the syntax error, I don't know why it's doing the syntax error, but it used to do it. Let me do this. Run. So it puts it in graphic mode. So now we're back in BASIC. So I can do draw 100, 100 to 200, 200. So this is me typing it in. There you go. So that's in immediate mode. That's not program it. That's in immediate mode. I don't know why it fails on graphic, but I suppose that is probably a bug that's in there, yeah, and we'll probably come try and figure out why it fails. You know, maybe it was because if you think about it, I never used this in immediate mode. I used it in coding mode all the time. So if we do circle, 100, 100, 45, 90, 0, 361. There we go. That's circle. Are you impressed that I remember my commands? So yeah, so that is so that is the crunch. That's the essence of a cruncher. It's not a wedge, it's a cruncher. Well, my Kaidos commands are immediate mode commands. So if you look in GitHub and look for Kaidos, that is a wedge. That is how to insert your commands in immediate mode or direct mode, yeah, and then perform your commands. So if you search for Kaidos, it's on my GitHub, which is a disk operating system for the 1541 and SD to IEC. That was a wedge that only works in direct mode, because if you type a program in one of those commands and then do list, it just has a fit. And if you run it, it goes syntax error. Right? I also did a load of videos about them. Oh yes, Kronos on Drift, yeah. I did a load of them. It was the first thing I converted, because I wanted to use the SD to IEC, and I thought, right, I'll convert my DOS commands and add the extra commands like mount and change directory and all that to it, so we could use it for SD to IEC. But they're all direct commands. They are not commands that you could put into a program. Yeah, I own loads. I mean, I've got them in my drawer here. I've even got this one, this big monster. That one. The only reason I've got this one is for the 128, because the SD to IECs that I've got are the mountable ones. Got that there. And the mountable ones, they are. Is it down here? Yeah. Yeah. I've got those which sit on the back. So it sits in the port, it's got the thing, it just sits on the back. And I've got 4 of these because they are permanently hooked into my 64's junk drawer full of SD to IEC. Yeah, there's a few in there. Right, so this stream we've done how a cruncher works, how to create so we're basically intercepting the basic jump and redirecting it to us. Then we're crunching the commands that are ours, and then when we finish with those, we pass it on to the basic cruncher for the Commodore BASIC to crunch their commands. And we've now created a lister, or uncruncher as they call it, or decoder, whatever you want to call it, which then takes all our tokenized command values and reconstitutes them back into user words that people can understand. So I think we'll call it there, because the other half's about to go to bed. Hello. You've been enjoying YouTube? Yeah? You've been enjoying YouTube? You photo bombing my stream again, eh? Hey? Yeah? Alright, out you go. Go on, out you go. So, in the next stream, we will do the next 2 that are important for having Well, this is it. I mean, everybody's game coding, and I didn't want to have to do it. I mean, I've done Neptune Lander, and that spawned Neptune Lander Elite by C64 Mark, which is a fantastic game, right? Fantastic game. I've got WauloK that's done Toxic Frenzy that I've helped sort out his problems, and I thought, I'm doing Grid Runner and Hunchback, all games, and I thought, right, let's do a stream that's not game related but is more application related. But this is real hardcore stuff. You Reynolds Lander. Hey up, mate. You caught my stream. So, and I didn't want to do another game. So I thought, right, we'll do an application. I thought this would be the next good one because I've got a word processor one I want to do as well. So, the next stream we'll do the evaluation of the tokenizing. So basically what that means is we evaluate it and find where we need to go, and then the last one is the execution of the command, where it actually performs the command. And then once we've got all those two in place, then we can start building our commands in future episodes. So we've got the two hard ones out of the way, which is the cruncher and the lister. They're the two hard ones. The other two are not too bad. So hopefully by the next stream we'll have the graphic command up and running, and maybe the screen command. So as WauloK has someone got give me bits? Someone give me bits? Oh, Microman, thank you very much. Thank you for the 50 bits. Thank you. So, as WauloK has just arrived to my stream, so he's probably just woken up, I'm about to finish the stream. Alright guys, well, thank you very much for watching. Is anybody online? Oh, Hazemaker's online. So, we will raid Hazemaker, and I will see you in the next stream. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.